So, today we're going to be studying surface area. I want to start out with yesterday. Our learning target was how to find volume. We talked about volume being the formula of length times width times height. We also talked about how volume is, and I'm going to kind of show this up here, but volume is literally the tissues inside the box. It is how much inside something is. That is what we did yesterday. Today, we're going to be doing surface area. We're going to be talking about what I call how much cardboard makes up this tissue box. If we were to unfold it, if we were to fold it, surface area is used all over the place, especially in building what I call furniture, boxes, a house. I mean, to be honest, the walls of the house. Couple things. First, I'm going to start off by showing you some shapes. Okay. This one, the tissue box, is, you already know, probably a rectangular prism. Right. Prisms are flat on each end. Okay. I've always tried to remember prisms by prisms we're taught in science class. Usually it's in the section that's about light and how when light goes through a prism and it comes out the other side of rainbow. Okay. Prisms are flat on each side. And a couple different prisms here. Now, this is the actual shape. Here we go. If you unfold this thing, unfold it. Okay. I'm going to kind of show it two ways. It would be like this shape. Okay. This prism is unfolded like this. This is called a net of the shape. A net is just like, if you think about like a fishing net on the back of a big fishing boat, when they go out to the sea or the ocean, that net is all rolled up on that boat. And then when they go out in the middle of the ocean and they drop it off the back of the boat, it unrolls and it covers a lot of space. This is the same thing. What sixth graders have to do is not only know the shape, such as a rectangular prism, but they also have to know the net, what matches it, okay, and be able to find the area of each of the little whatevers. These happen to be squares or rectangles. There's rectangular prisms. The other thing is that with these shapes, these little flats on each side, I need you to understand that they can be anywhere. They can be here or here or here. These nets don't have one certain set way. So the nets can be made different ways. Okay? So that is a net of a rectangular prism. It's not easy to keep up with these words. Okay. The next one. Here we go. This one is a what? Triangular prism. Listen, if I fold this thing up, you see how each end would be flat? It's a triangular prism. Each one on the ends is triangles, and it's flat on each end. This is a triangular prism. Listen. We'll get to the sheet in just a second. I just kind of gave you that early because I was videoing. So just listen for a second. Okay. Triangular prisms. Made up of two triangles, some rectangles. These sometimes are all even, and sometimes they're different measurements. So we'll talk about that in a little bit. Okay. This one is a cube, and it's made of squares. That's right. I think it's kind of silly. We got all these hard names, and then it's a cube. We would know if they give you a net of this cube, and let's say they only give you one number, then you know that every other wall is the same length. Okay? We'll talk about that one in a minute. Once again, these little flats can be here, here, anywhere. It just matters which person has made the net. Okay? There's the way it looks. Okay. Now, those are some of the prisms. Now we're going to talk pyramids. Pyramids, I think of like Egypt. They come to a point. This is the first one. This is a rectangular prism, even though that looks like a square. When I fold it up, okay, I'm doing the best I can here, promise. It would come to a point, okay. Notice the bottom. It's still got the rectangle, okay? This rectangular pyramid, is made of 4 triangles and then that rectangle. So, we're going to need to know formulas of triangle area and rectangular square area, okay, which we already learned. So, another one. That one is a triangular pyramid. Comes to a point. Triangular pyramid. It's all made of triangles, okay? It's kind of like looking at this sheet. It just happens to be under here. We have to know the shape, and we have to know the net, okay? Now, the last one I want to show you is kind of silly, but I just want you to see it. I know I'm walking away, but this is how this would be unfolded. This would be a cylinder, and I know it's a hazelnut creamer thing, but I'm just showing the kids this is a cylinder, and that, I know it's kind of silly, but this is this shape. And the reason is that the top and the bottom would be the red lid, the bottom circle, okay? And then it's weird, you don't really think of this part as being a rectangle, but if you were to just cut it right there, and you could unfold it, it would be a rectangle. Like if you could slice it and just open it up. We're not finding the surface area of this, or a cone, or a sphere, because we do not work with circles. But you will be doing it probably next year, okay? We're just got to know the name of this thing, okay? So, here we go, okay? We're going to talk a few of the shapes, giving it names, okay? So let's start out here. We're going to start with just naming the actual shape. And I realize I just went over them, but here we go, okay? So, part of our learning target today would be, can we name 3-dimensional figures? Here we go. Okay, this one would be a what? Rectangular pyramid. Because it comes to a point. Okay. This one, the base is a triangle, so it would be a triangular pyramid. Okay. The bases are circles, so we know it's a cylinder. Okay. Okay. Going on.
Well, I was just thinking, it was like, would that be the thing for a sphere? Would that be the
It has to do with that. Cone. Oh, I didn't mean to give you the answer so quick. I'm sorry. Okay. Well, it's funny because, like, cone is the easiest. Like, to me, it's not a fancy name. Seems like they would give us a fancy name for this thing, but it is just a cone. It's based off a circle. Okay, and I'll show you it as a net in just a second. This one is a sphere, and I always say sphere with PH. It's S-P-H-E-R-E is how you spell sphere. Okay, a ball, any kind of round ball. Okay. Number 6 is a rectangular pyramid. Okay, base of it being like a rectangle. Okay, this one, be careful. To me, they highlighted the wrong side. This is a, what is on each end? Triangle. So these are triangular prism. And it's based on this triangle on the end. Okay. Number 8, rectangular prism. And number 9, cube. Once again, if you see something drawn like this, maybe they only give you one number, then you assume the rest of the numbers are the same. Okay?
Wait,
A cube.
do we have to find the area of the shape part?
We're going to be doing it in just a little bit. Okay, now, that is the shape, what I call folded up. That is the normal shape. Now, we're going to be looking at the net. So, looking at this side, okay? Now it is unfolded, okay? It says, look at the net of the figure below and provide the name of the object. Be specific. Okay, this one is a cylinder. Okay, and they've got these circles attached. Okay, listen, this goes with that. So if you're looking at this number 5 right here, these two go together. So if this was about right here, it'd be bigger than that. And attached to that, which it should be attached to it, it is a cone. Yes. We're not used to seeing the circle of the cone because we think of ice cream cones and we fill up the circle in the top with ice cream. But that cone has got a circle as a base. Okay? Okay. This one would be a cube. Number 2 would be a cube. I'm kind of jumping around. This triangular what? Pyramid. Triangular pyramid. Take it slow. Okay. On Friday's 100-point test, we got to be able to name these things. Okay. Number 3 is a rectangular pyramid. Because the base of it is a rectangle. Okay. This one is a rectangular prism. Prisms are flat on each end. These are going to come to a point. Okay. And number 4, triangular prism. I know that this kind of looks a little weird, but these are triangles on the ends. Triangular prism. And then this one is a rectangular pyramid. I'm running out of space. Okay. Okay. Now, couple things. We did volume yesterday, and volume was cubed. It had the little 3 at the end, okay? We are back to 2, exactly. We are back to finding areas, okay? Because it's flat, yes, and we're doing just surface. Now, I have said this all day. I'm hoping you do this. I would write a little 2 above the word area. Hopefully that'll remind us that we're doing area. Okay. And then the other thing is I have asked my students to write down the 2 formulas that we will be using. The area of a triangle is base times height divided by 2. And then the other one we'll be using is the area of a rectangle, which is just base times height. We luckily will not really be doing anything with trapezoids or parallelograms. Okay? We're only really using these 2. Now, Friday, you got to have those 2 memorized and know which ones to use where. Okay? But those 2 are the main ones. Hint, hint. You got to know them. Yeah, and they're the easiest ones, yes. Eventually you will do the other shapes, but it's just 6th grade. We just start with these. Okay. Now, here we go. There is a specific amount of information that I will need from you in order to count for credit. And what I mean by that is showing your work. Okay. let's start out, it says name the figure and find the surface area. Okay, start out. What is the name of this figure? Triangular prism. So, I am going to fill that in. If you'd like. Okay. Now, this one is a triangular prism. Based on the triangles, if you were to fold them up, it would be flat. Okay. Now, here is the key to this. I need some work to be able to give you credit. You can't just say, I knew it was this, because there's too much involved in this just to spit out an answer. So watch. I'm going to kind of show you what I need. Okay. Let's start out with this rectangle. We're going to have to find the surface area of this rectangle. Well, we know that a rectangle is base times height. Correct? Okay. So, it is an 11 by what? Ah, now I want you to think about it. What is that wall? Ah, it is 3 because it is the same as that one. Height. Yeah, that arrow needs to be up a little bit. But that, now let me show you something.
That makes no sense. I thought it was
okay, so look, like that could be the base. The base could be 3 and the height is 11. Either way, 11 times 3 is 33. Now, I want you to look at something. Do you see these little dashy marks? That means those 3 are all that length. 3, 3, and 3. So that one is the same as that one. Okay. Now, if that rectangle is 33.
Do we have to connect them all?
Okay. No,
Like
just
how
look.
many?
Just look. Just look. This one would still be 11 by 3. So this one would be 33. And this one would still be 11 by 3 because that wall's 3. So it would be 33. That is enough work to prove to me that you knew the formula, you knew how to fill it out, and you knew the answer. That's showing me, you don't have to show it for each rectangle because it's shown right there. Okay. Now, the triangle. I'm sorry, yes. 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 You talking about the triangle? Yeah. Now, wait a minute. The rectangle height, this is the same as that. Because when you fold it up, it is... One second. I'm trying to grab a shape here. Okay. Here's the weird part. And I personally think they almost tried to trick us this way. When you fold this thing up, do you see how that touches that? So let me show you up here. When I fold it up, that corner, that wall touches that wall. So that wall is going to touch that wall. So if this wall is 3, what they're saying is this wall is 3, that wall is 3. And that wall, when it folds up, it's kind of weird, it touches that wall. Do you see that? A little bit? It's kind of easier sometimes if you look at this shape and then you touch the walls together, you go, oh, okay, so that would be the same as that. Okay? Do y'all see that? Like this right here, okay, when I fold it, that touches that. It's the same length.
Yeah.
So down here, this would touch this. So that's why it is an 11 by 3 and it's 33. Okay? That 2.6 is honestly pointing to this dotted line. So it's the height of the triangle. Does that make sense? Does that make sense? Right. Well, do you see how I got 33 on that one? Okay. So, like, you see the 11, though. Okay. This wall. Look at this one unfolded. When I fold this thing up, that wall is the same as that wall. It's the same length. So since, let me look, since one side is 3, and they've got the little dashy marks, okay, those dashy marks mean each side is 3. This is 3, this is 3, this is 3. So when I fold this thing up and these two touch, they're going to be the same length. So that one's 3, that means that one's 3. Okay? You've got to be able to visualize these things like folded and unfolded. And it's not always easy. Some of us are very able to do this. You're good at like spatial stuff. You can look at something and go, yeah, I think that chair will fit in that corner. And then the rest of us are over here going, I got to push it over there and see if it works. We're all different in the way we see these things. So we kind of have to work together and looking. Okay. So our rectangles, we got 3 by 11s. Now, the triangle, I want you to think about this. If this side is 3, then this side is 3. And the height is 2.6. So, I'm going to go over here. And I'm just drawing a little arrow kind of pointing off to the side. I know it's base times height divided by 2. It's 3 times 2.6 divided by 2. Okay, we do get our handy-dandy calculators finally. So 3 times 2.6, 7.8. Divided by 2 is 3.9. Okay, I'm just going to put it right there. Okay, now. Oh, sorry. Yeah. How about that? Okay, so that 3.9 that I've written up there. It's going to look weird, but I'm going to write it in there. I don't know. I'm going to try this pencil. No, let me try this blue pen. Okay, that 3.9 stands for this triangle and this triangle. Okay, now, here's the key to this. You've written in all the areas of each shape. But if we were to put it all together to find the surface, we got to add them all up. So, 3 33s are 99 plus 3.9 plus 3.9 equals 106.8. I go back and I look. It is inches and it is squared because it is area. This is enough work to prove to me you knew what you did. It's not hard. You've got to show me something though. Okay? You can't just look at, I can't tomorrow walk in and go, I just knew it was 106.8. No. You got to show me some work. Yeah. The final answer, I added up these 3, which is 99, plus 3.9 plus 3.9. You're going to add up all the sides together. Okay? This is the weird thing. I can't give you I can't say this is what you're going to do on every problem because every problem is different. And that's the hard part. Okay, let's look at example 2 here. Okay, example 2, what shape is it? Triangular pyramid. Okay, now, with a triangular pyramid, looking at the shapes, they're all triangles. So, I'm just going to go up over here. I'm going to write area equals base times height divided by 2, because that's the formula for a triangle. Okay, now, I need you to think about it. I need a base and a height. Well, the height's right there. It's 5. What is the base? 7.2, because of these little dashy marks. That means those 3 lines are the same length. So, it is 7.2 times 5 divided by 2. Yes, 36 divided by 2 is 18. Now, that 18 is one triangle. But because they're all the same base and height, they're all 18. So 18 times 4 gets you your final answer. 72. Yes, 72 millimeters squared. If you put in there like 18s, that kind of helps me to know, yep, you were on the right track. I might be able to give partial credit, like if you only multiplied it times 3 or something, I could at least maybe give some partial credit. Yes? Yes, yes. They'll all be, thank goodness, they're all based on rectangles and triangles. Some are easier than others, yes. Okay, let's look at the third one, example 3 here. Okay, so like example 3, the shape name is rectangular pyramid, yes. Okay, now this one is built off of 2 different shapes. I want you to see something, because I want you to learn this now. If you see a shape and it looks like a square, and they only give you one measurement, you got to kind of assume that the other sides are also 4.5. Now, slow down. I got some kids adding this today. Listen, base times height. 4.5 times 4.5. 20.25. So in this box is 20.25. Okay, that's just the rectangular square in the middle. Does that make sense? Everybody good? Okay, now I need the triangles. Okay, the triangles, what is this base? 4.5. And the height is 8. So, thinking about the formula, it's base times height divided by 2. Base is 4.5. Height is 8 divided by 2. Handy dandy calculator. It is 36 divided by 2. Area equals 18. Now, think about it. That triangle's 18, but what else is 18? Every other triangle. So you've got to kind of slow down. Some of y'all will go too fast and forget to add, or you'll tell me your final answer is 18. The final answer is we got to do what? Add them all up. So I got to add, I'm doing 18 times 4. I got 72 plus 20.25. 92.25 centimeters squared. You gotta show me some work. Okay. Well, the last one's actually the easiest. Why? They're all squares. And listen, this is why I was trying to show y'all earlier that if they only give you one number, it's kind of shocking. Like they only give you this one side. That means you got to just assume that the other ones are the same length.
What did you do on example 3 to get what you got? Do you add or multiply 20.25 to 18?
You got to add them. But there's 4 18s. So you'd add 18 4 times plus that. Okay. Now, so if we're doing a base times height, it is a 14 times 14, which equals 196. Yeah, 196. Okay, that means every box is 196. Okay? Don't forget, don't come down here and just tell me it's 196 because I have to count it wrong. It is a cube, and it's basically 196 times 6. Yes, 1,176 feet square. And it is a cube. Okay? Listen, the weird thing is these shapes can be unfolded different ways. So you got to be willing to kind of look at each one and I call it pick it apart and put it back together. Now, I want to show you a few things before I let you loose on your homework. Yes? Because there's 6 of them.
Cube is like a house, like with like house measurements, they say cubic feet.
Cubic feet, yep.
Cubic whatever.
Yep, because that's how many cubes fit it. Yep. Now, on your homework, listen, this is your homework sheet. It looks like this, okay? Looks like this, if you're wondering what it looks like. Okay. I need to show you a few things, because I don't want you stumped when you get home. Listen, this thing is just unfolded differently. What shape is this? Rectangular pyramid. This is a rectangular pyramid. It just looks weird because they unfolded it differently. Okay, these are both 5s, and the height is 8. Okay. Now, look at number 2. It is missing a letter. All of the triangles are congruent. That means they are all the same size. All these triangles. Notice, these little dashy marks mean they're all 20. They're all congruent. Put a T on the end. Okay. Look at this one. This one's pretty, I think you're good on this one. Just watch the measurements. But this one, I need you to all look. I'm trying to help you. If you won't look up here, you might get it wrong. Okay. Each side of this, you've got to slow down on some of these because they're not all the same rectangle. I need you to look. This is a 21, but what is this? 13. This wall would be touching this wall. So it is a 21 by 13. So this rectangle would be a 21 by 13. Okay? You got to kind of slow down. Ah, some of you are seeing it. The middle one is 21 by 10. Listen, 21, the base right there is 10. That is 10 going up and down. So it is a 21 by 10. 21 by 10. Now the triangle, the base is 10. Does that make sense? That's a 10. And the height is 12 divided by 2. So basically those 13s need to go what I call kind of down there. And then put it all together. Okay? Now, take your time. Be working on these things. Right now, I'm going to be working on them also. We will go over the answers tomorrow. Thank you.
Every advanced period, just do worksheet with us.
Not really. It's just happened the last few days. Okay. I'm trying to stop it.